Hey guys, welcome back from April break to geometry, your favorite subject. We're gonna go right into Unit 4, Day 2 notes. And after this, I'm pretty sure there's only maybe one more day of notes. This might be the last day of notes for Unit 4, and then you're pretty much done with geometry, so it's gonna be really easy from here on out. So take your time. All right, so the first one is finding a missing angle in a quadrilateral. So Unit 4 is all about the quadrilaterals, which are just four-sided figures. And the most important piece of information that you need to know about this is that the interior angles of a quadrilateral all add up to 360 degrees. So if I want to find this x, all I'm going to do is I'm going to add up all the angles that they give me. So 52 plus 127 plus 88 plus x and set it equal to 360 degrees. And if I use my calculator, or if you use your calculator here or in your head, you got 52 plus 127 plus 88 is 267 plus x is equal to 360 minus the 267. So once we add them all up, we subtract it from 360 and we get 93. So the value of that x angle is 93 degrees. And that's a very simple topic. The next page is a little bit trickier. So what I'm going to do here is I'm going to be giving you guys another document that you can look at while you're doing these topics in ALEKS, because that document will truly help you to figure out what are parallelograms and what are rectangles, and obviously what are quadrilaterals as well. So the first one is kind of similar to what we learned about in the last day, and that comes from this Venn diagram. So this Venn diagram right here is the most important piece of information that you're going to need to be able to figure out if these statements are true or false. So the first one says every square is a parallelogram. If we look at our Venn diagram, the squares do in fact fall within the blue. The squares do in fact fall within the blue parallelograms circles. So that means that that must be a true statement. Okay. If you look at the next one, it says every quadrilateral is a rectangle. Okay. So look at all the quadrilaterals. Everything in the giant circle out here is a quadrilateral. So all of these, anything that is inside this big black circle is a quadrilateral. Are all of them rectangles? No, they are not. So therefore, this is a false statement. In the next one, it says every rhombus is a parallelogram. Well, look at the rhombus. If you look at the little rhombus ones, they're the ones in green. Sorry, I was looking at the rectangles. The ones in green, do the ones in green fall in the bubble in blue? Yes, they do, because they are parallelograms. So that is a true statement. And the last one, it says every rhombus with four right angles is a square. Okay, so if you look at the rhombuses again, the rhombus are green, right? And if I tilt that rhombus so that it becomes four right angles, is that in fact the definition of a square? Yes, it is. So that means this is also a true statement. So you have true, false, true, true. Okay? Again, use the Venn diagram to figure out what is true and what is false. Now, this is where the extra sheet of paper is going to come in handy that I handed to you guys. So basically with this topic in ALEKS, you have to determine whether they are rectangles or parallelograms. First of all, right off the back, they are all going to be quadrilaterals, so you can check those off every time. You can check off the quadrilateral one every time because they are all four-sided figures, okay? So that's the definition of a quadrilateral. Now, when we're looking at parallelograms, we're looking to see if something is a parallelogram. A parallelogram has two features. It has actually three features. Opposite angles are congruent, or opposite sides are congruent, or they are also parallel. So opposite angles or sides are congruent or parallel. Okay, that is one definition of, or two definitions really, of a parallelogram. And another one is that diagonals in a parallelogram bisect each other, which means they cut each other in half. So this is what you're really looking for to determine if any of these are parallelograms. So if you look in the first picture, those little symbols tell us that the angles opposite one another are equal to one another or congruent to one another. Is that one of the qualities of a parallelogram? Yes, it is. So we check off that this is a parallelogram. In the next picture, you can see a couple different things in this picture. We have that the opposite sides are parallel. We also have that the diagonals are getting cut. So is this a parallelogram? Yes, it is. Opposite angles are parallel, and we even have the diagonals bisect each other. Okay? Then if you look at the last one has opposite angles congruent, right? In fact, it has all of the angles are congruent. So that is a feature of a parallelogram, so therefore it is a parallelogram. So all three of these are pictures of parallelograms. Then we need to look at whether they are a rectangle. So if I'm just going to highlight in red, or I'm going to write in red what the only different quality of a rectangle is compared to the qualities of a parallelogram. So to be a parallelogram, you have to have one of those features that I listed. And then on top of those features, because rectangles are parallelograms, on top of those features, you need to have 4 right angles. So remember, you have to have 4 right angles on top of those features, or you could have how can I explain this? All diagonals are congruent to one another. So all diagonals are congruent to one another. Those are the 2 extra features of a rectangle that make it a rectangle. So in the first one, do we have 4 right angles? Nope, we don't. So therefore, that is not a rectangle, and I will not mark it off. In the next one, do we have 4 right angles? Well, we don't know that for sure, but do we have all diagonals congruent? Yeah, they all have the same marking. So therefore, this is a rectangle in the second figure. In the last figure, the only piece of information we have is that all of the angles are congruent. Well, remember from the first topic on this day, all angles add up to be 360 degrees. So if all of the angles are equal, what is 360 divided by 4? It's 90 degrees. So all of those angles, they may all be equal, but they also all make 90 degrees. So is this a rectangle? Is that one of the qualities of a rectangle? Yes, it is. So those are your 2 pictures of rectangles, okay? So for these topics, you're going to given 3 pictures. So you're really going to have to analyze all 3 pictures to see if it's a parallelogram and if it's a rectangle. But we know right off the bat that they're always quadrilaterals. They're all going to be quadrilaterals, okay? In the next topic in ALEKS, it's very similar, except this time you're just going to classify whether it's a parallelogram or not. So let me just rewrite down here what the qualities of a parallelogram are. Remember, opposite sides are congruent, opposite angles are congruent, diagonals bisect one another, which means they cut them in half. And the same thing with these. Not only that, opposite angles are opposite sides would be parallel as well. Okay, so those are all the features of a parallelogram. Now that we know all those features, we can tell based on the picture and the markings that are on it whether it's a parallelogram or not. So in our first picture, we have a couple different markings here. The markings say that this is congruent to this, and they say this is congruent to that. Well, in order for diagonals to bisect each other, which is one of our features of a parallelogram, it would need to look something like this. The diagonals would have to cross one another, and they would have to be cut like this so that it's even on both sides, okay? So since our picture is not cut like that, we know that this is not necessarily a parallelogram. In the picture over to the right, now in this one, they ask if it's a parallelogram or not. So let's look at the features that they give us. first they have that first they have that opposite sides are congruent, and then they have that opposite sides, those same opposite sides are parallel. So are those in fact the qualities of a parallelogram? Yes, they are. So therefore, this is a parallelogram. All right, in the next one, let's look at what we have. We have opposite angles are congruent, and then we have opposite sides are parallel. Are those in fact properties or characteristics of a parallelogram? Yes, they are. So this is a parallelogram. And let's look at the last one. In the last one, the qualities that they show here are opposite angles are congruent. Is that in fact a quality of a parallelogram? Yes, it is. So this is a picture of a parallelogram. Okay? So you really have to look at the properties, use the cheat sheet that I provided to you guys to try to figure these out in ALEKS, and let me know if you have questions. All right, good luck.